Hello guys. Hello guys. In this given tutorial video, I'm going to teach you the application of differentiation in calculation of velocity and acceleration. So in most cases, you are always given the displacement function. So you need to understand something called the displacement. So I got displacement. Displacement is always denoted by an S. So this is the distance covered in a specified direction. Then you also have the velocity of a particle. The velocity of a particle, this one is just the displacement over time. It's always denoted by a v. The velocity, this one is denoted by v. Then you also have the acceleration of a given particle. The acceleration of a particle is denoted by a. Now displacement, velocity, and acceleration in that order. So this velocity, we always calculate it as displacement per unit time. Then acceleration is always velocity per unit time, the change in velocity per unit time. Now displacement is denoted by s, then you go to velocity, then you go to acceleration. So when you're given the displacement function, then you are being asked to get the velocity function. You want to move from displacement all the way downwards up to acceleration. So if you have been given the displacement function, you need to get the velocity function. We differentiate to get the velocity function. So when you move from top going to bottom, we differentiate. So the process involved here is called differentiation. Now, having displacement function, we obtain the velocity function by differentiating the displacement function. After differentiating the displacement function, then we obtain velocity function. We have the velocity function now. To obtain an acceleration function, we differentiate the velocity function to get the acceleration function. So the displacement, velocity, and acceleration is always arranged in this order. Now, let us do examples of questions involving the application of differentiation in calculation of velocity and acceleration. Now, in the example given on the board, we are being asked now the displacement s meters covered by a moving particle after t seconds is given by s equal to 2t cubed plus 4t squared minus 8t plus 3. Then find velocity at t equal to 2 and amount 2 we got at t equal to 3. Then the instant at which the particle is at rest. Now, let me go direct to the question. Now the question says now the displacement of a particle is given by s, that is part A. S equal to 2t cubed plus 4t squared minus 8t plus 3. Now the order is displacement, velocity, then acceleration. Now we have been asked to find the acceleration now. Here, we need to find the acceleration. We need to find the velocity. We have begun the displacement to find the velocity now. Now for us to find the velocity, given the displacement is denoted by s. Now to find the velocity, we are going to differentiate once to obtain a velocity function. Now the velocity of our particle now. Velocity v, we differentiate displacement once. So 3 multiplied by 2, we got 6t. Then the power of t reduces by 1. It will be 6t squared minus 2 multiplied by 4 is an 8. Then t power 1. Then minus 8. So we got no t after 3. So this is the velocity function v equal to 6t squared minus 8t plus, this one should be plus 8t minus 8. Now to find the velocity at t equal to 2 seconds, so we substitute t with 2. So Roman 1, the velocity at t equal to 2 seconds, so it will be v equal to 6 into bracket 2 into bracket squared plus 8 into bracket 2 minus 8. So velocity at t equal to 2 seconds, v This one is 6 multiplied by 4, 24 plus 16, 40 minus 8 becomes 32 meters per second. So that is the velocity at t equal to 2 seconds. That is Roman 1. Now when you go to Roman 2, we have at t equal to 3 seconds now. Velocity at t equal to 3 seconds. Now we come again and say v, velocity function was equal to 6t squared plus 8t minus 8. Now we got to substitute t with 3. So it will be 6 into bracket 3 squared minus 8 into bracket 3 plus 8 in bracket 3 minus 8. This one gives you 6 by 9, that is 54 plus 24, that is 88 minus 8. That gives you 70 meters per second. So the velocity at t equal to 3 gets you 70 meters per second. Now the instant at which the particle is at rest. Instant at which the particle is at rest. Any particle which is at rest means that the particle is not in motion. So the particle is at rest. It only implies that the velocity of that given particle, when the particle is at rest, the value of v equal to 0. So we're going to take the velocity function equated to 0. So we got 6t squared plus 8t minus 8 equal to 0. So you can divide by 2 by 2 by 2 by 2. So you got 3t squared plus 4t minus 4 equal to 0. So now we can apply the quadratic formula to get the value of t. So the value of a, the coefficient of t squared here is equal to 3. The coefficient of t, that becomes value of b is equal to 4. The coefficient of c is equal to negative 4. So the value of t in the quadratic formula is minus b, that is minus 4 plus or minus square root of b squared, that is 4 squared, gets you 16 minus 4 into bracket a, which is 3, multiplied by negative 4. Close the bracket. Everything all over 2a. 2 multiplied by 3, that is a 6. So the value of t, the instant at which it becomes minus 4 plus or minus square root of, this is 16 plus 48. 16 plus 48. 48 divided by 6. So this gets the value of t. T is equal to minus 4 plus or minus, so 16 plus 48, that gives 64. Square root of 64 is an 8 over 6. So minus 4 plus 8, that gives you 4 over 6, or minus 4 minus 8, that gives you minus 12 over 6. So the value of t is equal to 2 over 3. When you simplify this one, gets 2 over 3, or minus 2. But because t is time, so we are going to use the first one. So the value at which, the instant at which the particle is at rest is 2 over 3 seconds. So that is how we do. That is the first question. Now go to the second question. The second question asked us that, this is the question on the screen. The question says, the velocity v of a particle moving in a straight line after t seconds is given by v equal to t minus 70 squared, where t is time in seconds. Calculate the acceleration at t equal to 2 seconds. So we got displacement, velocity, and acceleration. So that is the order that we always advise people to use. So now to find we have been given the velocity function. To find the acceleration function, we differentiate going downwards. So we need to differentiate. Now, part A of the question, the velocity function equal to v is equal to t minus 70 squared. Now we got the velocity function, we need to find the acceleration function. We need to differentiate the velocity function once. So acceleration function A is equal to, differentiating t is t power 1. This one just reduces to 1. Then minus 2 by 7 is 14. Then t. Now acceleration at t equal to 2. So Roman 1 at t equal to 2 seconds. So acceleration we substitute where we have t, we put 2. 1 minus 14 into bracket 2. So this is equal to minus 27. The acceleration is equal to, this is 28, from 1 is minus 27 meters per squared second. That is Roman 1. It's as simple as this one. Now Roman 2 t equal to 5. So we got acceleration function is 1 minus 14 into bracket 5 because t is equal to 5. So 14 by 5, that's a 70. So the answer here becomes minus 69 meters per squared second. So that is part A. It is very easy to solve as the way I'm doing it. Coming to part B, the instant at which the acceleration equal to 0. So acceleration is equal to 0. So acceleration function, which is 1 minus 14t, we equate it to 0. So we are going to have negative 14 crossing the equal sign. This negative 14 becomes 14 on the other side. So we got 14t equal to 1. So the value of t, we divide both sides by 14 by 14. So t equal to 1 over 14 seconds. It is just as simple as this one. There's nothing to struggle about such kind of questions. So subscribe for more updates, and I know you are going to enjoy my classes and my content.